You are welcome to this session. So in this session, we will discuss miscellaneous exercise and part 5 of the chapter Integral Calculus, Integration. This is presented by S. Murugayan. So until the fourth session, and we have completed up to 24 question from the miscellaneous exercise, and today we are going to start from 25th question. Okay, let us start our discussion. Question number 25. What is the question? Integral pi by 2 lower limit, upper limit pi, and e power x into 1 minus sin x the denominator 1 minus cos x dx. Then we have to rearrange the given integrand e power x into 1 minus sin x by 1 minus cos x in the form of e power x into f of x plus f base of x. Then the integral of e power x into f of x plus f base of x will be equal to f of x into e power x. We have to identify f of x and f base of x, and from the factor 1 minus sin x by 1 minus cos x. Let us take I pi by 2 is the lower limit, upper limit pi e power x 1 minus sin x will be written 2 times sin x by 2 and cos x by 2 using trigonometric identity. 1 minus cos x and 2 sin square x by 2. 1 minus cos x is 2 sin square x by 2 and dx. And further simplification, and pi by 2 lower limit, upper limit pi e power x and 1 by 2 cosecant square x by 2. 1 by 2 1 by 2 sin square x by 2, 1 by 2 cosecant square x by 2. Then minus 2 and 2 cancel, sin and sin cancel, cos by sin, cot x by 2 and dx. Listen, derivative of cot theta minus cosecant square theta. So derivative of minus cot x by 2, 1 by 2 cosecant square x by 2. Here we have identified f of x including the sign minus cot x by 2, and its derivative f dash of x must be applying chain rule minus 1 by 2 cosecant square x by 2. So this is of the form f of x plus f dash of x in the e power x. Understood? So what is its integrated value? E power x into minus and cot x by 2 is integrated value. We have to apply a lower limit and upper limit to get the final answer. And taking minus outside, upper limit e power pi and cot pi by 2. Okay, minus e power pi by 2 cot x equal to pi by 2 means cot pi by 4. This implies, and cot pi by 2 0. Yes, cos pi by 2 by sin pi by 2. The first term 0 minus e power pi by 2 and cot pi by 4 1. And therefore the final answer of the question 25 and e power pi by 2. This is the final answer, e power. So what is the final answer? And therefore I is equal to e power and pi by 2. This is the answer. Copy it. We'll go to the next question. Question number 26. We are going to discuss now and go through and copy it. Question number 26. 0 to pi by 4. 0 to pi by 4. Sin x cos x in the numerator. Sin x and cos x in the numerator. The denominator cos power 4x and plus sin power 4x. The denominator. Okay. Now what to do? Sin x cos x can be a derivative of sin square x. What is the differential of sin square x and 2 sin x cos x and dx? So sin x cos x dx is 1 by 2 d of sin square x. So let us take sin square x equal to u. That u equal to sin square x, and this implies sin x dx or du is equal to 2 sin x cos x and dx. Dear student, whenever we follow substitution method in case of definite integral, the limit also have to be changed for the newly introduced variable. So when x equal to 0, u equal to sin square 0, 0. When x equal to pi by 4, u equal to sin square pi by 4, that is 1 by 2. Lower limit is 0, upper limit 1 by 2. The same, the question would be written in terms of newly introduced variable u. The lower limit is 0, upper limit of u 1 by 2. Sin x cos x dx is 1 by 2 du. 1 by 2 du. The denominator and cos power 4 mean 1 minus u square the whole square. 1 minus u square sin square x the whole square plus u. It is 1 minus u square. U equal to sin square x mean the denominator 1 minus u cos square x. So 1 minus u the whole square. 1 minus u the whole square plus u square. Okay, and this implies I will be equal to 1 by 2 integral lower limit is 0, upper limit 1 by 2 du u square plus u square 2u square, okay, minus 2u and plus 1. Yes, u is nothing but sin square x. This is u square 1 minus u sin square x, 1 minus u cos square x the whole square So on expansion 1 minus 2u plus u square plus 1 more u square, 2u square minus 2u plus 1. So we can take 2 outside, I equal to 1 by 4, 0 to 1 by 2 du, the denominator u square minus u plus 1 by 2. Dear student, and we have to apply completion square. Completion square. Applying completion square, I is 1 by 4 integral with the lower limit 0, upper limit 1 by 2 du. The denominator u minus 1 by 2 the whole square. Okay, and 1 by 2 minus 1 by 4. 1 by 2 minus 1 by 4 is nothing but and plus 1 by 4. Plus 1 by 4, 1 by 2 the whole square. Okay, so 1 by 2 minus 1 by 4, 1 by 4, 1 by 4 is written 1 by 2 whole square. And dear student, u minus 1 by 2 is taken as L. L means linear. What is dl? If we take L is u minus 1 by 2 means dl is the same as du. So we can apply the formula straight away. Whenever the dl equal to du, we need not go to further substitution. It can be integrated straight away and following appropriate formula. Which formula we have to apply? This is of the form dl by l square plus a square. Dl and du equal 1 by a tan inverse of l by a. 1 by a, that is a is 1 by 2, 1 by a 2 tan inverse of and 2u minus 1, that's all. 2u minus 1 and lower limit, upper limit. 1 by 4 into 2, 1 by 2. Take upper limit, u equal to 1 by 2, tan inverse of 0, 0. Go to lower limit, tan inverse of minus 1 minus pi by 4, minus or minus pi by 4 plus pi by 4. Okay, the final result, therefore final result I equal to pi by 8. Final result I equal to pi by 8. Just copy it. We will go to next question, question number 27, and go through it. 27. Integral with the lower limit 0, upper limit pi by 2. The numerator cos square x, the denominator cos square x, and plus 4 sin square x and dx. Okay. So if you look at the integrand, this is a combination of second degree term cos square, denominator cos square and sin square. If we do not have the cos square x in the numerator, this is easy type of question. Just we have to divide numerator and denominator by, because of second degree cos square x, the numerator will be secant square, the denominator is a function of tan x. And taking u equal to tan x, it can be integrated. Apply upper and lower limit, it can be evaluated easily. Now we need some conversion, and cos square x would be written 1 plus cos 2x by 2. Sin square x would be written 1 minus cos 2x by 2. Okay. If we substitute For cos square and sin square, the conversion formula, this is not a substitution. We are not introducing new variable, just try to restructure, try to simplify the given integrand to avoid second degree term. So the numerator 1 plus cos 2x by 2, 1 plus cos 2x alone I have taken. The denominator, this 2 is common. Instead of cos square x, 1 plus cos 2x alone taken, plus 4 into sin square x, 1 minus cos 2x. So the numerator denominator, the common denominator 2, 2, 2 everywhere cancel, and dx. Am I correct? Then I will be equal to 0 to pi by 2, 1 plus and cos 2x. Look at the denominator. How many cos 2x? And 4 into 1, 4, 4 plus 1, 5, minus 3 cos 2x. Okay, 3 cos 2x at dx. So in order to simplify, we can try to write the numerator in term of 5 minus 3 cos 2x. The numerator should be written a function of 5 minus 3 cos 2x. This is the shortcut. We have to write numerator in term of and 3 minus cos 2x, because the same cos, if it is sin, we can try note substitution method, because cos 2x would be derivative of sin 2x would be derivative of cos 2x. We are numerator cos 2x, denominator also cos 2x. So the adjustment required. So let us try to write numerator as a function of and 5 minus entire denominator, 5 minus 3 cos 2x. What to do? 0 to pi by 2. Then we can start our adjustment from cos, minus 3 cos 2x required. So minus 1 by 3. Okay. Then minus 3 and cos 2x. Minus 1 by 3 into minus 3 cos 2x, and we need 5. Okay. Then what is the extra constant? And minus 5 by 3 should be adjusted, so plus 5 by 3, and already existing constant 1. This is numerator. The denominator 5 minus and 3 cos 2x and dx. Just copy it. I will continue here. Then I will be equal to the first term minus 3 cos 2x plus 5 divided by minus 3 cos 2x plus 5. Only minus 1 by 3 is left. Minus 1 by 3 integral of dx, a lower limit 0, upper limit pi by 2. This first term. Second term 5 by 3 plus 1, 8 by 3 can be taken outside, and 0 to pi by 2, and dx by 5 minus 3. Here we need conversion. Then cos 2x is 1 minus tan square x by 1 plus tan square x. Okay, then I will be equal to, and dx, integral of dx x, and pi by 2 into minus 1 by 3 minus pi by 6 first term, plus 8 by 3 integral 0 to pi by 2, 1 plus tan square x becomes secant square x dx in the numerator, denominator 5 plus 5 tan square x, 5 minus 3 2, 5 tan square x and 3 tan square x plus 5 plus 3 8 tan square x, correct? Then 5 into 1 plus tan square x, so 5 plus 5 tan square x minus 3 plus 3 tan square x. 5 minus 3 is 2 and 5 tan square x plus 3 tan square x, 8 tan square x. And if we take tan x is u, then secant square x dx, no, what will come? This is du. Okay. Then we have to integrate and copy it. We'll go to the next page. Okay. I equal to minus pi by 6 minus pi by 6 plus 8 by 3 plus 8 by 3 and 0 to pi by 2. Secant square is nothing but d of tan x. The denominator and 3 plus 8 tan square x, correct? And 2, not 3, 2 plus 8 tan square x. This should be 2. Let us take now for the second part u equal to, not u, already we have taken u. I think this is the first substitution. Here u equal to tan x and du is secant square x dx. What is the new limit? When x equal to 0, tan 0, 0. When x equal to pi by 2, tan pi by 2 is not defined. So I will be equal to minus pi by 6 plus, we can take 8 outside and 8 and 8 cancel, 1 by 3, 0 to infinity du by 2 by 8, that is 1 by 4, 1 by 2 the whole square plus u square. Then minus pi by 6 plus 1 by 3. Integral of this tan inverse, that is 1 by 8 tan inverse 2 tan inverse of 2u and 0 to infinity. Okay. Then minus pi by 6 plus 2 by 3. Upper limit tan inverse of infinity pi by 2. Lower limit tan inverse of 0, 0 and 2 and 2 cancel, and minus pi by 6 and pi by 3 is overall pi by 6 is the final answer. Pi by 6 is the final answer, and go through it. This is one of the most important question. We'll go to the next question, and question number 28. And lower limit pi by 6, upper limit pi by 3, sin x plus cos x in the numerator, the denominator a root of sine and 2x. This is another important question. Dear student, whenever you come across the combination of sin x plus cos x and sin 2x, or sin x minus cos x and sin 2x, the sin 2x should be written as a function of the sin x minus cos x. The numerator in terms of sin x plus cos x means sin 2x should be written in terms of sin x minus cos x. So how to write sin x minus cos x the whole square is 1 minus sin 2x. From this we can write what is sin 2x. Sin 2x equal to 1 minus of sin x minus cos x the whole square. Okay. Then how to restructure the given question? I pi by 6 lower limit, pi by 3 upper limit, okay, and sin x plus cos x dx the numerator, a denominator inside the square root 1 minus of sin x minus cos x the whole square should be taken. Now we can introduce substitution u equal to sin x minus cos x. What will be du? Derivative of sin x cos x, derivative of minus cos x plus sin x, and dx. The entire numerator will be du, and we need to change limits also. Then what is I? When u equal to pi by 6, when x equal to pi by 6, what about u? Sin pi by 6 1 by 2 and cos pi by 6 and root 3 by 2. So 1 by 2 minus root 3 by 2 is a combination of rational. So better no, you can avoid a substitution. What to do? We can write straight away. This is of the form d of sin x minus cos x by root of 1 minus sin x minus cos x square means what is the integral of this? Sin inverse of sin x minus cos x. That's all. Sin inverse of sin x minus cos x and lower limit pi by 6, upper limit pi by 3. Then sin inverse of upper limit sin pi by 3 minus cos pi by 3, the same result will come, minus sin inverse of sin pi by 6 minus cos pi by 6. Okay. Then sin inverse of sin pi by 6 1 by root 3 by 2 minus 1 by 2 minus sin inverse of 1 by 2 minus root 3 by 2. We can take sin inverse of, apply the concept sin inverse of negative x is nothing but negative of sin inverse of x. Look at the value. Root 3 by 2 minus 1 by 2, here 1 by 2 minus root 3 by 2 means it can be written I equal to 2 times minus or minus plus 2 times sin inverse of root of 3 minus 1 by 2. Root of 3 minus 1 by and 2. So this is the final answer, and copy it. So dear student, let us wind up today's session with the question number 28, and part number 6 we can begin with question number 29. Thank you students.